Welcome to Introduction to Computer Science, Databases and SQL. This is Lecture C. The component, Introduction to Computer Science, is a basic overview of computer architecture, data organization, representation and structure, structure of programming languages, networking and data communication. It also includes the basic terminology of computing. The learning objectives for databases and SQL are to define and describe the purpose of databases, define a relational database, describe data modeling and normalization, describe the structured query language or SQL, define the basic data operations for relational databases and how to implement them in SQL, design a simple relational database and create corresponding SQL commands. Examine the structure of a healthcare database component. This lecture will demonstrate how SQL is used for creating, accessing, and updating databases. Structured Query Language, or SQL, is the language commonly used to manage and access a relational database. This language is a standard established by the American National Standards Institute, or ANSI, International Organization for Standardization, or ISO, and International Electrotechnical Commission, or IEC. Nevertheless, each database management system, or DBMS, may interpret the standard differently or offer proprietary extensions to the language. There is no guarantee that one set of SQL commands will work exactly the same way on another vendor's system. Portability is difficult from one DBMS to another. However, most common commands will operate in the same fashion. While the following examples show the use of a command line interface to access the database directly through SQL commands, this is certainly not the only way to access a database. Databases can also be accessed through graphical user interfaces, as well as programs that issue SQL commands through defined system interfaces. The following slides will explore some basic SQL commands. To create a contacts database of individuals, their companies, and the addresses associated with those companies, use the SQL command create database, with the database name specified at the end of the command line. It is always helpful to use a meaningful name. So for this example, the database will be called contacts. In order to delete a database, the command drop database with the database name specified is used. After the database is defined, the data tables can be created. This can be achieved with an SQL command where the table name and information about the columns contained in the database table are specified. The column information contains the name of the column as well as the type of information contained inside the specific column. Additional information about the table may also be specified. SQL has an extensive set of options available. In the following slides, several examples of how to use the create command to create the tables will be explored. Just as with the database itself, a table may need to be deleted when it no longer serves its purpose. To do this, use the drop table command with appropriate options. This table shows basic data types used in SQL. While SQL is a standard language, the data types, formats, and range limit of values may be vendor-specific. However, the data types shown in the table are the most common in various SQL versions. An integer data type is used to store whole numbers with no decimal points. To store a number with a decimal point, the data type needs to be identified as a float type. If it is important to record information about when an event occurred, then both date and time data types will be indicated. Finally, there are two formats for storing textual information, char and varchar. A char is used to store strings of a known length, such as a zip code. A varchar data type is used to store text strings where the actual length is variable, such as a person's name. This slide shows the steps to create a table for company information. It is important to remember that the company name, address, and city are of variable length, while the state will be stored as a fixed, two-character abbreviation. The row will need to be uniquely identified. ID will be used as an identifier. Finally, each column must have a meaningful name, preferably one that has an easily understandable meaning to anyone accessing the database, such as name. Notice that there are a few more options used in the command on this slide. The ID column is identified as having an integer type, as well as an auto_increment option, which instructs the system to keep track of the value, incrementing it every time a new row is added. The name, address, and city are represented as variable text strings of up to 50 characters. However, a larger value may need to be specified if names or addresses longer than 50 characters are to be stored. It was determined that the two-letter abbreviations would be used for the state names, as indicated by the char field value of 2. And finally, the primary or unique key for the company table is the ID column. This table shows the structure for the person table. The person's first name and last name are stored separately to enable sorting by last name only, and each person's name is associated with the company. As in the company table, ID is used for the primary key in this table. After names have been determined for the columns, the create table command is used to create the table as shown. This table is very similar to the create company table on the previous screen, with the addition of the foreign key, company_ID, which ties the person to the appropriate company. The addition of references company, open parenthesis, ID, close parenthesis to this command tells the database that the company ID column in the person table is tied to the primary key, open parenthesis, ID, close parenthesis column in the company database, ensuring that the company ID values are consistent between the company and person tables. Also note that it is not necessary to use the same name for the foreign key in both tables. In this example, it is named company_ID in the person table and ID in the company table. After the tables are created, then the show tables command can be used at the command line interface to confirm that the company and person tables have been correctly structured in the contacts database. To verify the correct columns and data types are in the tables, a show columns from command is issued for each table. Along with displaying additional detailed information, this will confirm that the individual tables have the expected names and data types, and that the primary and foreign keys, which are abbreviated in this table as PRI and MUL, have been correctly identified. There are 4 basic operations in an information system: adding, retrieving, deleting, and modifying information. SQL statements can be used to change the contents of database information, providing more ease and organization in the maintenance of large amounts of data. The first operation, add, is accomplished with the insert command in SQL. The table where information is to be inserted and the specific values for the row must be identified. This slide shows the steps to add company entries. The value for each entry in the values field lines up with the equivalent entry in the column field. For example, city is specified as the third column in the first insert statement, and Portland is being used in the third column in the values field. It is imperative that the order of the values matches the order of the columns to prevent inserting wrong values into the columns. Note that a value is not specified for the ID column. This was set to be auto-increment when the table was created, so the system automatically enters the value. Also notice that the text strings are surrounded by single quotation marks. This is how the SQL command line interpreter recognizes the beginning and end of text. Now that companies are entered into the database, the individuals associated with the companies can be added. For each entry, the first and last names need to be specified, again using single quotes around the text strings and the company key. Note that this is now much simpler, as only the company key associated with the person needs to be entered, rather than all of the company information. The next slide will describe how the values of 1 and 2 for the company IDs are obtained. Retrieval, or selecting specific information to view, is another basic operation. In this slide, the SQL statement select from company retrieves all data for every column in the table. The asterisk instructs the system to show all information. Notice that each company is numbered in the ID column. This happens automatically when the auto_increment option is utilized, as illustrated in an earlier slide. When using a file system, it can be a challenge to sort contact information by last name. By adding order by to the SQL statement, the system will display the information sorted by last name while maintaining the original ID and company_ID values. A search, however, may not require that all data in a record be returned. Instead of an asterisk to request everything, the names of the desired columns can be indicated in the SQL statement. This slide shows retrieval of only the first and last names of the table records. To retrieve only the first and last names of the people who are associated with a specific company, company ID 1 for example, a where company_ID equals 1 clause is added to the statement. Since ID 1 in this table is Community Hospital, the resulting table will show that Sriveni Sharma and Karthik Subramanian are associated with that organization. Previous slides have demonstrated how to retrieve information from just one table. This slide shows how to retrieve information from both tables at once. This requires a more complex SQL statement that joins the tables and specifies how the tables are related. When the two tables were created, primary keys were identified for both tables, and the company ID column in the person table connected to the ID column in the company table. The SQL command select asterisk from person join company on person.company underscore ID equals company ID semicolon connects the two tables and provides complete information on all the contacts and the companies. This slide demonstrates an SQL statement that combines several actions: retrieving a person's name, retrieving the name of their associated company, and sorting by last name. The SQL statement shown here selects the columns to display, indicates that information is to be collected from multiple tables, and specifies the sort order. SQL provides a large amount of flexibility in examining the data stored in a database. While this lecture has explored only a few of the options for retrieving data, there are many more SQL retrieval options that provide the user with greater control of how database data are viewed. The third basic function is deleting data, as shown on this slide. The SQL delete statement identifies the table where data will be deleted and the specific entry that is being deleted. Technically, the where constraint is optional, but without it, all information in the table will be deleted. A very specific SQL statement will ensure that only the specified data will be removed. There are many ways to do this. Just Rachel could be specified, but in case there are multiple Rachels, it is best to use both the first and last names. The ID column could have been specified instead once Rachel's ID value was retrieved. Because it is the unique key into the table, this would guarantee that the correct row was removed. The final basic function is modifying data. SQL uses an update statement for this, where the table is identified, the columns with the data that require change are identified, the new data is identified, and the rows that are being modified are identified. This slide shows a two-step process to modify a company's name from Community Hospital, Inc. to Community General. First, the unique row ID will be identified using a select statement that will retrieve information on all of the companies in the database. This search shows that Community Hospital, Inc. has a row ID of 1, which can now be referenced in the SQL command to change the data for the hospital name. The update statement specifies company as the table, sets the contents of the name column to Community General, and specifies that the modification is to take place in the row with the ID for the hospital. Notice again the use of single quotes to identify a text string. It is also important to know that there is no limit on the number of rows that can be changed in a single update statement. As with the delete statement, it is very important to correctly identify the rows to be changed by using the where clause. After the company name has been changed in the appropriate row in the company table, the change to the row information can be verified by issuing the SQL select statement and looking at the command output to ensure that the name change from Community Hospital, Inc. to Community General was successful. A final query that pulls data from both the person and company tables, as shown on this slide, can also verify that the information has been successfully modified. This concludes Lecture C of Databases and SQL. In summary, this lecture demonstrated how SQL is used for creating, accessing, and updating databases. Using a contacts database as an example, SQL statements were used to create tables, insert data, update data, retrieve or select data, and delete data.